In this question, we're given several linear inequalities, and we are asked to represent the region on the coordinate grid where all of them are satisfied. The first inequality is a strict inequality. That is, y is greater than x, it's not greater than or equal to. To represent the inequality region, I need to first draw the lines y equals x, because that's similar to our first inequality. I'm just writing it with an equal sign. X equals 1, and y plus 2x take away 5 is equal to 0. And this last inequality, or this last equation now that I've written it like an equation, is best written in the form y equals mx plus c. So that's y equals minus 2x plus 5. And this should be x equals minus 1, not 1. So what I'm going to do now is draw each of these lines onto my grid. The first one is the line y equals x, and we should know that that is a straight line which goes through the origin and passes through 1, 1, 2, 2, 3, 3, and so on. Because the inequality was y is greater than x, which is a strict inequality, I need to make this a dot like that. We now draw the line x is equal to minus 1, which is just a vertical. And finally, we want to draw the line y is equal to minus 2x plus 5. And the easiest way to do this is with a table. Work out the values of y for 3 different values of x. So x and y. So we have when x is 0, y is just equal to 5, because minus 2 times 0 is 0. When x is equal to 1, I have minus 2 plus 5, which is 3. And when x is equal to 3, I get minus 6 plus 5, which is going to be minus 1. So I know that my graph for y equals minus 2x plus 5 will pass through 0, 5, 1, 3, and 3, minus 1. So if I want to draw the line, and again it's greater than or equal to, that's what the inequality, less than or equal to, that's what the inequality was. So we use a solid line. There's our line. So we've now drawn the 3 lines, and we need to indicate where the region actually is. So if we look at each of the lines in turn, the first one, y is greater than x, is the dotted line. And because y is greater than x is the equation of the line, we are interested in all of the points which lie above the line. That is, all of the points where y is greater than x. So if we look, say, here, the x value is about 0.5 and the y value is greater at 1.5. So we're interested in all of the points above the line, and I've indicated that with some arrows. The second line, x is greater than or equal to minus 1, well, that's all of the points which are on the line, x equals minus 1, or are to the right of this line, because it's greater than or equal to minus 1. Finally, the last line is the line which we have written in the form y equals minus 2x plus 5. But if we leave the inequality sign in, that's y is less than or equal to minus 2x plus 5. Because of the less than or equal to sign, we are interested in all of the points that lie on the line or are less than the line. So they're either equal to the line, they're equal to the points on the line, or they are below it. So we can see that the region indicated is to the right of x equals minus 1, it's above y equals x, and it is below or on the line y is equal to minus 2x plus 5. So this must be the region contained in here. It must be what I am now highlighting as the region. And you've got to be clear to the examiner that what we are doing is highlighting the region that we want. So there's our region, and I'm going to label it R. Here's a question for you to try. On some graph paper with appropriate axes drawn as shown, I'd like you to label the region R which satisfies the 3 inequalities. Pause the video now and have a go, and when you're ready to go through the answer, press play. Let's go through the answer. So firstly, I'm going to draw the line y is equal to minus 2x minus 4. And a table will help me. You might see another way. You might just say, well, it goes through minus 4 on the y-axis, and it has gradient minus 2, but we'll just do it this way to start us off. So 0, 1, 2, just for example. So we have when x is 0, y is equal to minus 4. When x is 1, y is minus 6. When x is 2, we have minus 4, take away 4, which is minus 8. So we have the following points: 0, minus 4, 1, minus 6, and 2, minus 8. And it, obviously because the gradient is minus 2, this makes sense. If you go to the right by 1, you go down by 2. So let's draw this line. And I'm using a solid line because the inequality is greater than or equal to. Now, for the second one, I want to draw the line y is equal to 3x plus 5, and I'm going to use the same method as before. Just pick any three x values, substitute them in. I get 5, 8, and 6 plus 5 is 11. So any two values will do really, but 3 is just a way of making sure. 8, and then obviously 11. Well, actually, my graph doesn't go that high, so I'll just use those two, and then maybe minus 1. Minus 3 plus 5 is 2. So I have this. So now let's draw the line, and this time it has to be a dotted line because the inequality is y is less than 3x plus 5. Finally, we have x is less than or equal to 1. So for this point, so for this line, I'm just going to draw x equals 1, which is here. And because it is not a strict inequality, I'm going to use a solid line. And there we go. Now, to indicate where the region is, I'm going to use the same method as before with the arrows. So we have y is greater than or equal to minus 2x minus 4. That was this line. And if we are interested in points which are greater than or equal to this, or where y is greater than or equal to this, we want points which are above the line, or on the line, because this is not a strict inequality. Secondly, I want points which are less than 3x plus 5. Y equals 3x plus 5 was the dotted line. Because I want points such that y is less than 3x plus 5, I need all the points which are below the line, less than the line if you like. Finally, I want all of the points where x is less than or equal to 1. So that is all of the points which are either on this line here, or they are to the left of it. So we're looking at the points enclosed by the triangle. So I'll shade in that now. There we go. Let's label it R. And that is our completed region. You may be asked to describe a region. In this question, we want to write down the inequalities which describe the shaded region R. To do this, I need to work out the equations of the lines which make up the lines that form the region. If I look at the blue line, first of all, this one, I can see that it has y-intercept 6, so I know that I'm going to have the form y equals mx plus 6. And to work out the gradient, the simplest way is to look at how far down we go on the line if we go across by 1. So if I say fix a point here at the point minus 3, 9, if I go to the right by 1 unit, then the line goes down by 1 as well. So that means the gradient is minus 1, across 1, down 1. So I have y equals minus x plus 6, that's my blue line. And if I then consider the red line here, I can see that it's just the line x is equal to minus 2. If I look at the green line, I can see that it goes through the y-axis at minus 1, so we know we have y equals mx minus 1. And to find what m is, you could consider just by looking at it what is the gradient. Another way would be to substitute a value in for x and the corresponding value for y. So for example, when x is 2, y is equal to 3. So I can say that 3 is equal to 2x take away 1, not 2x take away 1, sorry, 2m, x is 2, 2m take away 1, and I could then solve for m, giving me 2m equals 4, and then m is equal to 4 divided by 2, which is just 2. So we have in this graph, or in this line, on this line, y is equal to 2x minus 1. So those are our lines, but now we need to consider, oh my goodness. So those are the equations of the lines that we have, but we need to notice that some of them are dotted and some of them are not. We can see that r is contained to the right of the red dotted line. So we're interested in points where x is bigger than minus 2, not bigger than or equal to, because we have a dotted line. We're interested in points which are below the blue line. So that means that we need to have a less than sign. So we have y is less than minus x plus 6, because the equation of the line was y equals minus x plus 6. And finally, we're interested in points which are above this green line. And because it's a solid line, it's not going to be a strict inequality. It could include the line. So we're interested in points now, y is greater than or equal to 2x, take away 1. And that's our region fully described. Here's a question for you to try. Please pause the video now and have a go, and when you're ready to go through the answers, press play. This is how we would describe the shaded region R this time. Firstly, let's look at this blue line. We should know, or we should be able to work out, that it has equation y equals x plus 4. The orange line has equation y is equal to, so cross 1 down 2 minus 2x minus 4, because the y-intercept's minus 4. And the line here is just the line x is equal to 2. And again, we consider, are we above, to the right, to the left, or below the lines? So if we look at the blue line again, we are clearly looking at points which are below that line, or on the line because it's solid, so we are interested in y is less than or equal to x plus 4. We're interested in points which are to the left of the line x is equal to 2, so we want x is less than 2. And again, it's because it's a dotted line that we have the strict inequality. We're interested in points which are above the orange line, so that's going to be y is greater than minus 2x plus 4. And these three inequalities would successfully describe the shaded region R. Here's a final question for you to try. Please pause the video now and have a go at it. And when you're ready for the answer, press play. And also note, it's slightly different to the others because we have a horizontal line. This is how we would describe the shaded region in this last question. We have a green line which is horizontal. So every point on this line has y coordinate equal to 6. So this is the line y is equal to 6. So we're interested in points which are below this line. So we can see the inequality will be y is less than 6. But let's finish doing all the lines first. Let's look at the blue line. So the blue line has equation y is equal to, well, it goes to the origin. So, and if we go across when we go down 1, so it's just y equals minus x. And the solid red line has equation y is equal to, and if we go across when we go up 2, so this is just y equals 2x. We're interested in points which are above the blue line, not including it because it's a dotted line. So that's going to be y greater than minus x. We're interested in points which are above the red line, so that's going to be all the points where y is bigger than or equal to 2x. And I say or equal to because it's a solid line, so it could include the line itself. So the inequalities which satisfy the region are y is greater than minus x, y is greater than or equal to 2x, and at the same time y is less than 6. So these three inequalities will satisfy the shaded region.